You can start this question before. Make sure you reset your timer. Okay, you already reset. Okay,
Yes.
now you just start this question now. Okay.
Okay, so today we're going to solve LeetCode number 78 called subsets. So we're given a unique integer array nums of unique elements. That means that there are no duplicates in the array, and we want to return all possible subsets. So as you can see, the solution set cannot contain duplicate subsets. So for example, you have 1, 2 here, you can't have 2 of 1. So this counts as a duplicate because this is we're seeing duplicates by the frequency. And as you can see as well in the input, there is an empty array as well. So yeah, so first of all, obviously the output is going to be a list. So I'm going to have results.
Yeah, well, I have one question. How to avoid duplicate?
We avoid duplicating by recursively calling a smaller subportion of this array by moving the pointer here and here and here to the right until we get to the end of the subarray. And then we're going to backtrack, and we're actually, for example, we're going to add 1 to the array, then we're going to add 2 to the array, then we're going to add 3 to the array, and then we're going to add 1 and 3 to the array.
Okay.
Because we're going to backtrack, and then we're going to add 2, 3 to the array, and then we're going to add 1, 3 to the array, and then we're going to add 3.
Okay, okay. Yes, sound good.
Yep.
Sound good, yeah.
So, yep. So basically, this is a problem of recursion. So the way, again, it happens is we're going to keep moving to the right of the array, and we're going to basically iterate through the array using recursion. So let's define a recursive function here where we're going to, let's just call it I. We're going to start at 0, and we're going to have a current, array, you can say. We're going to have a list of lists that we're going to append because, as you can see, that's the format of the output. So, okay, so cool. So we're on the first index here, and we're going to first define our base case because every recursive call needs a base case. So basically, if I is bigger than or equal to length of nums, that means we're out of bounds to the right. So in this case, we want to actually append a copy of our sublist because we've essentially hit the boundary where we've added all the elements into our sublist. And then we want to return out of it so that we can backtrack. So this is the base case. If we haven't hit the base case, then we're going to first append the actual number right now to our sublist. So cur.append nums of I, and then we're going to call recursively, we're going to call the next element over with current. So current is now 1 instead of it started as an empty list. And we're going to keep calling, we're going to keep going until, for example, here, and then we're going to hit our base case. We're going to append a copy of current, and then we're going to return, and we're going to backtrack, or we're going to pop the element. So cool. So now current is supposed to look like 1, 2, 3. So after we pop it, current is supposed to be 1, 2. Cool. So we got rid of the 3. Next, we're actually going to call the recursion once more. Why? Because we want 1, 3 instead now. Because we added 1, we've added 1, 2, we've added 1, 2, 3, and now we want to start at 1, 3. And then we want 2, 3, and then we want 3. So I know this can be a bit confusing, but that's generally how we avoid duplicates. And so, yeah, so that's basically how you solve this question.
Yeah, I think I can understand, yeah.
So we're going to run it. Hopefully this works. Nope, invalid syntax. Okay.
Invalid
Problem
syntax.
is that this is supposed to do, we're not supposed to, the recursion, we're supposed to define this as the variable here. I is not defined. This is supposed to be 0. So yeah,
whoa,
as you can see,
okay.
This is, yeah, subsets. So
I think it's do very well. Okay, thank you.